Welcome to all. This is a concept-based question, very important. 35. 35 I will solve. 36 you have to solve. Same way. See here, UVL is from here to here. 36 will be this way. That I will give homework for you or exercise with the mini solution, short class. Read the question. A beam is of length 20 meter. It is simply supported at 5.5 meter from left end and also at 4.5 from right end. So the total length they told 20 meter. See, they told that's all given in the question given. That's all. See, they told this total length is 20 meter. Then they told 5.5 one support, 4.5 other support. So this gap will come 10 meter. From 20 you subtract. Or they can give 10 meter span between supports, left overhang 5.5, right overhang of 4.5. Most important is loading. It is loaded by uniformly varying load of intensity 0 at the left extreme end and linearly increases to 60 kN per meter at the right extreme end. Very important concept-based question. Your lot of confusion will be avoided here now. Okay, start. Find reaction. The statement usual. Let VA upwards, VB upwards, usual, A and B. This I will remove now because this I want space some space I require for writing some statement here. Okay. First you write this statement, usual statement. Okay. Or in future, see, why waste time? Let VA upward and VB upward, B, etc., etc., A and B respectively. Okay. Now, class. Prepare a neat sketch here. See, this is A, this is B, I will call C here and D here. 5.5, 4.5, 10. Total, there is no place to mark here. If you want total length, it is 20 meter. Remember, you can see here, 20 meter. Now, one note you have to write. This can be solved very, very easily. But that I am doing last. First, to understand the struggling. Once you understand the struggling, then you will realize the importance of easy method. Okay, first, right here. First difficult method. First difficult, then easy. Okay, we will take sigma m about A0. See, you can do one thing. You can take sigma m about A0 and sigma V0, or you can do sigma about B0 and sigma V0. I will solve both of them. Okay, start. Suppose you decided to apply first sigma m about A equal to 0. Then, see here, if you see A here, left side loading will produce anti-clockwise, right side will produce clockwise. So, you have got a habit of separating. This time, separating is dangerous. You see the struggling. If you don't separate, you get the answer in one line. I will do last now. So, first a difficult one. So, we will separate. When you separate, you require the intensity here. See, you make a triangle here. This is 60 kilonewton per meter. This is the point D. You make this point as D and C here. Okay, D. This is C. See, somewhere here is the point A. Total length is 20 meter. From C to A is 5.5 meter. So, let the intensity at A be WA. What is the intensity at A? WA. Right here. Let you write here. I don't have space to write. Let W suffix A be intensity of UVL at the point A. Then from similar triangles, see, stand here. 60 divided by 20 equal to W at A divided by 5.5. 5.5. When you solve, you will get W at A equal to 16.5 kilonewton per meter. Okay. Now draw a neat sketch. See, this side triangle we will take one load. I will put light hash this way. This side full trapezium dot 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 dot. This is W. So this is one triangle 16.5, one trapezium from 16.5 to 60. Now how to take moment of trapezium triangle all so many times told. Those who are serious, you should study everything. So that I can't explain now. Take moment about A. Minus VB into 10, see, plus moment of, you write here, UVL from A up to D. See, from A to D, total load. This is trapezium, this is 10 meter, this is 4.5. We want full load here. So 10 plus 4.5 is 14.5. Make a note if you want. You write somewhere, see, if you want, you can make a note here. This is 14.5 meter. Okay, then total load will pass here, little this side. Okay, start. Area of the trapezium is total load. 16.5 plus 60 divided by 2 into 14.5 will give total load into, from here to line of action is this distance you want. So many times I told, if I want line of action here, it is this side plus twice of that side divided by this side plus that side into distance between the 2 points, 2 parallel sides divided by 3. Many times explained. If you are not properly studied, you have to blame yourself. That is clockwise. Then minus half into 5.5 into 16.5 is the total load into this distance is 1 by 3 of 5.5. VB will come 470 kilonewton. I calculate already. Sigma V0 upward positive plus VA plus VB minus, this time we want only total load. Splitting is not required. Full triangle. Half into 20 into 60 is the total load. Substitute for VB, you get VA 130 kilonewton. Then write, therefore, reactions at support will be, see here, VB equal to, how much you got? 470 kilonewton upward, positive. Negative means down you have to write. And VA equal to 130 kilonewton. Solution is over. Okay. Now do one thing. Make a note. You decided to make, once again write. You decided to take moment about A. Okay. Done. Moment about A. Then this side we will get triangle, that side you get trapezium. Right. But imagine you do not like trapezium. This also I told. You do not like trapezium. In that case, what you have to do? Left side triangle, right side trapezium, replaced by a rectangle. Rectangle means UDL and one right angle triangle. That is, see, I will do one thing now. This I remove now. Yes, this I can remove. I will put once again. This I am not removing. Okay, that is, see, separate sketch. This is 16.5. Okay. This is 60. This length is 5.5 meter. This is from here up to here, full 14.5 meter. Okay, this is A. This is D. This is C. Now this is equal to, see, this loading will be equal to, see, this I am not disturbing, this I will remain as it is. I replace only this trapezium, so equal to 1, see, it will come this way. From here to here, triangle. Okay. This intensity is 16.5. Then, see here, one rectangle of 16.5 only. Then, here 16.5, here 60, you get one triangle here. See, actually, it should be continuation of this line, this way. So, separately, this is 16.5. This will be 60 minus 16.5. 16.5 equal to, nowadays because of too much calculation, I lost my basic mathematical instinct of simple calculation, what to do. The 43.5 kilonewton per meter, 43.5 kN per meter. Then do one thing. Then, when you write the sketch next time, see, put the same sketch once again. When you put the sketch, this is this over, see. This is 16.5 kilonewton per meter, and then this is how much I told? 43.5 kilonewton per meter. To understand, stagger this one. Stagger. Okay. Now, separate. Okay. This all I'll remove now. This all I explained earlier. So those who are serious, they will easily understand. Okay. Now, I removed sigma v by mistake. Okay. Okay. Then, sigma m about a equal to 0. A equal to 0, take clockwise positive. Take moment about A. Minus VB into 10, anti-clockwise. I won't explain. Minus VB into 10 plus this UDL. 16.5 into total is 14.5 plus clockwise. 16.5 into 14.5 is the total load multiplied by, it will act through center here, into 16.5 by 2, then plus this uniformly varying load, half into total length is 14.5, 14.5 into 6, 43.5 is the total load multiplied by, see this total load, this is 14.5, it will pass somewhere here. This is 2 by 3, that is 1 by 3. From here, 2 by 3. Be careful, which is 2 by 3. 2 by 3 of 14.5. This side load over all clockwise minus this triangle load. Half into 5.5 into 16.5 is the total load multiplied by 1 by 3. This side, if I explain waste of time, of 5.5 equal to 0. You simplify, you will get VB equal to 470 kilonewton. Okay. Then sigma V equal to 0, take upward positive. Plus VA plus VB, VA plus VB. Now make a note here. We should not waste unnecessary time. Now we are not finding moment. We want only loading, total vertical load. In that case, why unnecessary you are splitting all? Waste of time. See, half into 5.5 into 16.5, 16.5 into 14.5. See, minus, by minus, all are downwards. Minus half into how much? 5.5 into 16.5. This load minus this load. That is 16.5 into 14.5 minus triangle load minus half into 14.5 into 43.5 equal to 0, or directly, see, splitting not required. See original diagram. See original diagram. See original diagram. This total load you want, half into 20 into 60, or directly minus half into, all are minus only, 20 into 60 also will do. This is easier, equal to 0. You get the value of VA. How? Substitute for VB. You write here. Substitute for VB, you get VA 130 kilonewton. 130 kilonewton. Okay. Again, same answer. Now, lastly, write, make a note. Make a note. We unnecessarily wasted time by splitting. I told splitting on either side is very helpful for UDL. Why? Not much work. that W into that length by 2 minus this W into this length into this length by 2. Who will struggle for where is the resultant line of action passes? But I told earlier, uniformly varying load, if you want moment somewhere in between, splitting is actually unnecessary complication. We will not split the load. Directly we will do it now. See now. Directly. You make a note here. None of this calculation now. See. Or no splitting. No splitting. Put the beam. See. Simply put the beam. kilonewton per meter. This is the reaction, this is reaction. Okay. This is your VA. This is your VB. This length is 5.5 meter. This is 10 meter. And this is 4.5 meter. And if you want total length, it is 20 meter required. Now, this complete load is full triangle. Resultant load will come somewhere here. See, this is the resultant for entire loading. Then, see here, this is a point A, this is a point B, CD. Take moment about A. Sigma m about A equal to 0, take clockwise positive, make a note here. If you want this distance, this is 2 by 3 of 20, whereas if you want this distance, it is 1 by 3 of 20. Therefore, minus VB into 10 plus directly total load. See, minus VB into 20, 10, VB into 10 plus, it will come this clockwise. See, half into 20 into 60, half into 20 into 60 is the total load multiplied by, see, moment about A you require. This is 2/3 of 20. This is 5.5. I want moment about A. So load into this distance is 2/3 of 20 minus 5.5. 5.5 equal to 0. 100% you get VB equal to plus 470 kilonewton. My guarantee. Then make sigma V equal to 0. Then sigma V0 upward positive plus VA plus VB minus full load half into 20 into 60 equal to 0. Substitute for VB, whatever you got, you get VA equal to plus 130 kilonewton, right? Oh, what speedy solution we got. So, in case of uniformly varying load, in case support is somewhere in between, then splitting is not better. Correctly observe the total load, decide where the total load is acting, whether it is left of A or right of A. If it is right of A, moment is clockwise. If it is left of A, moment is anti-clockwise. Then single stretch you can do it. Okay, make all this note. This question is over now. Now I will do one thing now. I will go for this type of load. I will do one thing. Same question I will solve once again by taking moment about B. Better to understand correctly. Okay, leave it. Okay, see now. Now or right here, class. Difficult you are doing, then easy. We decided sigma m about B equal to 0. Okay, we decided to take moment about B. In that case, see, put the sketch once again. This total length is 20 meter. You require intensity at B. Because that side, this side, you are splitting. So this is W at B. So right, from similar triangles, see, now you require this distance, 5.5 plus 10 meter, 15.5 meter. Then W at B divided by 15.5 equal to 60 divided by 20. W at B will come. See, easy solution last. 60 by 20 into 15.5. 46.5 kilonewton per meter. 46.5 kilonewton per meter. Kilonewton per meter. Now, draw a sketch. Remember, your purpose is to take moment about B. So, this is one reaction here, VA, somewhere here one more reaction, VB. See, now, moment about B you are taking, see, B, this is A. Therefore, this is one uniformly varying load. This becomes trapezium. This is 60 kilonewton per meter. This is W at B equal to 46.5 kilonewton per meter. Okay, then now this is 10 meter. And also this is how much? 5.5 meter. This is 4.5 meter. Okay, do this way. Then what you will do? We will take this triangle single stretch. So this total base, if you want, remember it is 10 plus 15, 15.5 meter. The resultant load will pass here. Will pass here now for this load, and distance from here to here will be, sorry, you are taking moment about B, correct? You are taking moment about B, okay. If you take moment about B, this distance will be 1 by 3 of this base is 15.5, and one more load will come here. For that one, you require a formula for trapezium. Okay, we already know it. Okay, start. Sigma m about B equal to 0. Take clockwise positive. Moment about B plus VA into 10. 10 meter is not visible properly. I change it. Plus VA into 10 minus moment of this load minus half into 15.5 into 46.5 is the total load downward from C to B, from C to B, into this distance is 1 by 3 of 15.5, that is anti-clockwise, then this is clockwise, plus this total load is, this I explained probably more infinite number of times. People who are not following, who have no interest in subject, don't study anything from me, into 46.5 plus twice of high time. I should start those things. See, I should not waste my energy unnecessarily into 4.5 by 3 equal to 0. This total load, the sum of these two divided by 2 into 4.5 total load from B to D, distance of line of action is this side plus twice of that side divided by this side plus that side into this distance by 3 equal to 0. You will get VA equal to, let's calculate. Where is calculator? Plus 130 kilonewton. Some will tell, sir, cheating. Okay, plus 130 kilonewton. Then sigma V equal to 0, upward positive. This time, right here, no splitting. We want only load. So you can write plus VA plus VB minus full load you want. Half into full is 20 into height is 60 equal to 0. Substitute for VA, whatever you got, you will get VB equal to plus 4, some will tell, plus 470 kilonewton. Okay, same answer, over. This is B. Now write, note. Now we are taking moment about B, and we are decided to split, because why? Concept problem. But when you look right side, you get a trapezium. We are afraid of trapezium. I am not afraid. You should write. Then at least that much you do it now. See, this will become up to here same, then this way, out of scale. Okay. This is 46.5 here. This is out of scale 46.5 kN per meter. And this difference is, write one more sketch. 60 minus 46.5 is 13.5 kilonewton per meter. 13.5 kilonewton per meter. I already explained how to get it now. Now do one thing. This rectangle and triangle take separately. Then if you take moment about A, moment about B, see, plus VA into 10 minus this load into this distance remains same, but here what you get? Here you will get here clockwise. See, one load acting here center, one load acting here. This load is B to D. You should write B to D UDL plus 46.5 intensity into 4.5 is the total load into 4.5 by 2. Write B to load B to D UDL plus once again half. You should write once again everything. Half into 4.5 into 13.5 is the total load into, from here to here is 2 by 3 of 4.5 equal to 0. You will get VA equal to 130 kilonewton. 130 kilonewton. Sigma V 0. Now this time, don't split now. Take the full triangle. See the original diagram. See original. VA plus VB minus half into 20 into 60 0. You get the value of VB. Or do one thing. VA plus VB minus half into 15.5 into 46.5 minus 46.5 into 4.5. Again minus half into 4.5 into 13.5. Do that way. Okay, now do one thing. Lastly, go for the easiest method. Actually, the splitting UDL is unnecessary complication. See, for UDL, splitting UVL, for UDL, splitting is helping for you, but not for UVL, or directly no splitting. Then see, within no time, solution is over, within no time, very fast. Already I told how to, but earlier you took moment about A, now you are taking moment about B. See, this reaction is VA, somewhere here reaction is VB, out of scale, this is 5.5 meter, this is 10 meter, this is 4.5 meter. You take the complete load, everything, once for all, 60 kN per meter. The full load, don't see here, resultant will come somewhere here. So the total resultant force will come here. And we want moment about B, this distance will be 1 by 3 of 20. Now see, if you take moment about B, A and B, sigma m about B0, take clockwise positive, plus VA into 10. These all, if you study thoroughly, understand, then my effort is really rewarded. Plus VA into 10 minus, why minus? See, resultant load comes here. 1/3 of 20 is 6 point something. This is 4.5. So anti-clockwise minus half into full load. Complete right here. Half into 20 into 60. The total load from C to D, entire load from C to D into, see, it will act somewhere here, one moment about B, into this distance is 1/3 of 20 minus 4.5 equal to 0. You will get the value of VA. How fast you got, see now? VA will come. I will really check now. Okay, For your benefit, I will really check. Half into 20 into 60 into bracket 20 by 3 minus 4.5 divided by 10. 130 kilonewton. Really I got. Honestly I got. No cheating. In the class some will tell, sir, you are not done it, sir. Why? Sir, because earlier you carefully you got the answer. You applied the trick. Now we are not doing, you are just telling us for our satisfaction that you are doing no, this time I really did it. Okay. Then lastly, sigma V0, why red color? Black color will do. Plus VA plus VB minus entire total load, half into 20 into 60 equal to 0. Substitute for VA, you get the value of VB. 470 kilonewton. Okay, see, solution is same. So I solved it 6 times today. Each finally answer came same. Now, what I will do is, I will give one more question for you this way. Now only I will give you, but with only answer. Those who are serious can do it. Okay. Depends upon even how serious you are. How serious you are depends. Question number 36 is a real question, not homework. Because why 36? So next is 37. I should note it. 36. Okay. But I will solve briefly. It's a real question. But I will tell everything for you, so you solve. With the answer I will give you. But briefly I will explain. This time I will not go for fractional value solve. See. 1 minute. It has to, if I use a wet cloth, it takes some around half minute, 1 minute to get dried up. Now, some problem. Dogs are barking there. Maybe they, okay, see. I will sketch directly. For the beam shown in a figure, find vertical reaction at supports. This way. See, this is one support here, one support here. This is 5 meter. This is 1.5 meter. This is 2 meter. Okay. 2 meter. 5, 2, 7, 8. To avoid fraction, what I will do is 8.5 into 6. I will give a multiple of 6 and 8.5 so that I can avoid fraction. That 3, 3, 3, 3, 2, 2, 2, 2, I don't like it. 5, 2, 8 into 30. 255 or 8 into 24. 204. This is 204 kilonewton per meter. This purpose is to see that decimals are, that recurring numbers are not recurring, that long numbers are avoided. A, B. Okay. Do one thing. See, right. First easy solution. Now first easy. See how fast you can solve. See now how fast you can solve. But you solve everything you solve, because why? Maybe you will tell, sir, I will go for easy only. No, no, no. When you study everything. Then only you get the grip. See, I will give easy solution first. This is A, this is B, this is VA, this is VB, distance wise, this is 2 meter, this is 5 meter, this is 1.5 meter. If you want entire length, it is 8.5 meter. See, take moment about A. Sigma m about A0. Take clockwise positive. Minus VB into 5, then plus this full load single stretch. It will act somewhere here. See, it will act here. And the distance from here will be 1 by 3 of 8.5. And distance from here is 2 by 3 of 8.5. Therefore, directly total load half into 8.5 into 204 is the total load into moment about A, this distance you want, that is 1/3 of 8.5 minus 2 equal to 0. you get the value of VB. Then you get the value of VA. I explained so much. Half into 8.5 into 204 equal to into bracket 8.5 by 3 minus 2 is 722.5 kilonewton. 722.5 kilonewton VB minus half into 8.5 into 204 will give you plus 144.5 kilonewton is the VA. Sigma V0, VA plus VB minus total load 0. Or, once again, easy solution. Sigma M about B0. Then, plus VA into 5, plus VA into 5, minus total load. Half into, how much it is? 8.5 into 204 is the total load into, space is not there. I want moment about B. See, into this distance is 2/3 of 8.5. 8.5 minus 1.5 equal to 0. Therefore, your VA will come. Actually, checking not required. Still, I will check it. Half, if anything is wrong, you can make out now. Half into 8.5 into 204 into bracket 2 by 3 of 8.5 minus 1.5 divided by 5. 722.5 VA plus 722.5 kilonewton is VA. Sigma V equal to 0. VA, you write VA plus VB minus half into 8.5 into 204 equal to 0. You get the value of VB plus how much VA got? VB got. No, there is something wrong here. One minute now. There is something wrong here. Half into 8.5 into 204 into bracket 1 by 3 of 8.5 minus 2 divided by 5. Oh, I not divide by 5. Half into 8.5 into 204 into bracket 1 by 3 of 8.5 minus 2 equal to, oh, this, I forgot divide by 5. 144.5 VB. Because I know that VA should come more. 144.5 kilonewton and VA will come 144.5 minus half into 8.5 into 204. 722.5. See, that's why it happened. 722.5. Yes, here I got correct answer. VA 722.5 VB will come plus 144.5 kilonewton. Okay, my work is over. Now it is for your talent. The splitting option I will tell now. I will explain. Answer is known for you. You work out. See, those who are serious will do it. I will not give any hint for you now. At least some effort from you. See now, correctly. You decided moment about A. Moment about A. Then, if you are going for splitting, this is one load, other load. This is how much? Oh, you. Diagram is inverted. This is 204 Kn parameter. Find this intensity. You should find it. I cannot give every time answer. Similar triangle, stand here. 204 minus 204 divided by 8.5 into 6.5. It will come 156 kilonewton per meter. That is your intensity at A. Then this is A, this is B, this is D, this is C. You should work out. Remember, you can't expect every day I will do it. 2 meter, 5 meter and this is 1.5 meter. If you want this triangle, 6.5 meter. Take moment about A. Okay, I will read it here. Minus VB into 5 plus half into, how much? Half into 6.5 into 756 into 1 by 3 of 6.5 minus trapezium. 156 plus 204 divided by 2 into 2 is the total load into bracket 156 plus twice of 204 divided by 156 plus 204 into 2 divided by 3. Your answer VB will come same what you got earlier. Sigma V0 full load, you get the answer. Or divide. One more sketch you write here. See, this is UDL and then UVL. If it is, this is 156, this will become 156 minus 204. That is 48 kN per meter. Then one load here, one load here, one load somewhere here. Work out. Or if you are taking moment about B, see, you should work. See, so much I explained. Then one option is get this is so much 204. This is 204 divided by 8.5 into 1.5. This will come 36. Supports are here. Okay. Now this side triangle will come. This side trapezium will come. Work out. Get the answer. Or if you are afraid of trapezium, one more sketch you write. This is 36. This also 36. This will be 188 kilonewton per meter. Then one triangle load here, one UDL, one UVL. Solve it and get the answer by taking moment about B. I explained first question very thoroughly. First of all, I should have given the question with the direct answer, but still I thought little help for you, briefly. Now it is your capacity and your dedication to solve this question and get the answer. Those who get the answer by all three options, 6 times you have to solve. Moment about A 3 times. Once full easiest method. Then one side triangle, one side trapezium. Then replace trapezium by rectangle and triangle. Then again moment about B also. First easy method, simple one line answer. Then right side triangle, left side trapezium. If you are afraid of trapezium, split the trapezium into rectangle and triangle and solve and get the answer. Okay. Now we'll meet next class 37. Thank you.